So before I get into the video, I would like to ask that you have this little bit of prerequisite knowledge before we begin. I would like to ask that you know what some basics of subnetting, so like the terminology, net ID, broadcast ID, that you know like how there's 32 bits in the subnet mask in total, how they're found through ones and zeros, how we get the numbers we get through the subnet mask, stuff like that. And then the second thing I would suggest for prerequisite knowledge is that you know your powers of 2, if you're doing this by hand or for efficiency. Otherwise, a calculator is fine. And the final thing I would like to ask you to know is how to convert from decimal to binary and back if you're doing this by hand. Now, for the sake of this video, I'm going to be using a calculator right here just to save time, because I do know how to do it, and if you know how to do it too, that's fine, but I just want to save time for the sake of the video. So, the question asks, what is the network address, broadcast address, and the subnet mask of this IP address right here? So, first what you're going to do, or what I like to do, is we're going to write out the IP address, okay? 2.118.204/19. So now the second thing I'm going to do is the first thing I look for is what class of subnet this is. Because if you look at this digit right here, if you know your classes of network, you would know that if it falls between 1 and 126, it is considered a Class A network. But here's the thing. Even though that's the case here, it's actually subnetted as a Class C network. And the reason it is for that is because there's 8 bits in the subnet mask, right? Or there's 32 bits in the subnet mask in total. But if you do the math, 8 bits would make 1255 octet, right? So 8 times 2 is 16. This is greater than 16. So that means I know that the subnet is going to look like this. It's going to be 255 dot something and then dot 0. So it's a Class B subnet. So be aware of that. That can be tricky sometimes. So knowing that it's a Class B, we know we draw the line between the network bits and the host bits right here. We draw the line right here. So I'll make a tiny letter here. So these are host bits, and these are network bits. This is our network. This is our host bits. So now that I saw that, the next thing I'm going to do is I am going to look and I am going to try and write out the subnet mask for the octet that we're going to be changing. So the octet that we're going to be changing is the first one on the host side, which is 118. So this is the first octet that we're going to be changing. Now, in this, if you think of the subnet mask, all right, so we got 255.255. So what are the bits remaining? Well, if this was /16, we would have 255.2550. So, but they borrowed 3 host bits, and as a result, they borrowed 3 host bits and gave it to the network. So there's 19 network bits in total. So if you think about it, 19 minus 16 is 3. So our sub, and you can write sub like this if you want, the bits of our subnet are going to be 1, 1, 1, right? And then 0, 0, 0, 0, 0. So we have 1, 2, 3, 4, 5, 6, 7, 8. Yep. So that's our subnet for the third octet right here, the first host one, in binary. Right? Okay. And now the next thing you're going to do is you're going to get the binary for the digit in the third octet in the given IP address. So we have 118 right here, right? So we're going to take that 118 and we are going to go from, let's see, decimal to binary. And then the decimal is 118. We're going to convert that. And now this is the number we have here, right? Now we have 1110, 110. Now if you count the digits here, notice that when we are dealing with like the IP address in binary, or we're dealing with the subnet mask in binary, it goes up to 255, right, before it clocks over. So we usually have 8 digits here, 8 binary digits right here, and this is only 7, but we can fill in the leading 0. So we see it's 1, 2, 3, 4, 5, 6, 7. So we can put a 0, a leading 0, right here that we otherwise could omit. So we're going to have a 0 here, and now we're just going to put the rest of these numbers down. So 1, 1, 1, oh, 1, just want to get that closer. Okay, 1, 1, 1, 0, 1, 1, 0. So now we have this 118 in binary, and we have our subnet mask in binary also for the third octet. Okay, so now to find the network ID, this is a bit like an addition problem, but not really. So basically what you're going to do is, I'll type this out on the side too, maybe that'll help, is what you're going to do is you are going to add 1 if there are 2 1s, and add 0 if there, are, or if there, I guess I could say if there is anything else, just to keep it simple. Okay, so what we're going to do, 1 plus 0, that's 0. 1 plus 1, that's 2 1s. We're going to put a 1 down. 1 plus 1 again, that's another 1. 0 plus 1, that's a 0. 0 plus 0, that's a 0. 0 plus 1, that's 0. 0 and 1, again, that's a 0. And then finally, 2 zeros. And this right here, this number right here is binary for our network ID. So again, if you know how to convert between the two, go ahead and be my guest. You can do it on paper if you want, but I'm just going to punch it into this machine right here to get them really quickly. I mean, you could probably also do it if you knew your powers of 2, but I'm going to do it in here for simplicity's sake. Okay? So, after we punch that in, we now have the decimal number 96. So, we know that for the network ID, the third octet has the number 96 in it. So now, for these questions, we can actually go ahead and write out the answer to the first question, right? So I'm going to do that right now. But before I do that, there's one more thing I want to do. I do want to find the subnet mask, just so I can explain something. So, if we go ahead and find the subnet mask, I will put the subnet mask right here. I'll do subnet mask. It is, so we know it's class B, so that's 255.255. This third digit here. So if we look at the binary, which we already figured out, so it's, again, and you can do the /2. So the 16 tells us it's 255.255, and then 3 bits. So how's it go? It goes 128 plus, because it's going to be 111, and then the rest are zeros, so we just add those 3 ones. So it's 128 plus 64 plus 32. What's that equal? 224, right? And then finally, since it's class B, the last digit's a 0. So now, with this subnet mask here, we are going to take, so we do have that number, so we're going to write out the proper network ID, right? So we're going to start with these two, since they're under the network side of the IP address. They're not going to change. Same thing, works the same way with the subnet. We know after doing our binary and converting it that this digit is 96. So we know that that digit right there is 96. And then the final digit for the network ID in this is going to be 0. And the reason it's 0 is because in the subnet mask it's 0, right? So we can say, I'm going to write this down here too, net ID for 19.22.118.204/19 equals this right here, 19.22.96.0. Alright? So, now, Another part of the question, so we already wrote our subnet mask, and there's another thing you can do to get the subnet mask too. What you can do is you can take 2 to the power of however many host bits are in the third octet. So in this case, there's 1, 2, 3, 4, 5 host bits, right? In the third octet of the subnet mask. So you take 2 to the power of 5, which is 32, and you take the number 256, and then you subtract that number, and that would also give you 224. That's another way to find your subnet mask, right? I usually like to just count the bits, and then because I know my decimals in the binary, I can come up with it pretty quickly. That's just another way to do it, though, if you'd like. So now we're going to try to find the broadcast address, right? Because the question asks for the network address, the broadcast address, and the subnet. Well, we already have the subnet right here. We already have the network ID right here, right? So what's the broadcast address? So if you look at the number of host bits, that are inside the Subnet Masks octet, or the third octet, and you look under the Subnet Mask, if you look at the number of host bits, if you take 2 to the power of however many host bits, and in this case, if you look, there's 5 of them, right? There's 5, 2 to the power of 5, and you can just calculate if you have to, is 32, correct? So, what we do is we go to our network ID, which is right here, and we go to the digit we changed, right? The 1 octet that we changed, in the third octet, and then we add 32 to it. So what's 96 plus 32? That is 128. So our next network ID, and you can write this out like this. Oh, let me change it to black so it matches. So we can do net ID 2 is 19.22.96 plus 32. So you just add the number each time for each number. So that is 128, right? Dot 0. So that's our second net ID. Now, the reason I have you find the second net ID is because if you find the second one, finding the broadcast ID is incredibly easy. So we don't even have to do any more of the, math. That's it. So now all we have to do is we have to basically just take 1 away from this. And by doing that, this actually becomes 127. And then remember we took 1 away from the far right, so it's 255. Right? So if we do that, that is our broadcast ID for the problem, right? And as you can see, I just punched in the numbers to check them, and if you look, they're all correct. So that's how you find the network ID for odd subnet masks, I guess you could say. Or subnet masks that don't follow the standard slash format, so like /8, /16, because then it's always 0 where the host bits are, or sorry, the host octets. But since it's not like /8, /16, or /24, we have to do a bit more work to find it. And there's probably other ways to do this. This is just how I do it. I try to keep it as simple as possible. Hope I explained it all right. I'm not really a teacher or anything, just something that I struggled with a bit. I thought I'd share it with the internet, if anybody needed help finding that. And that'll be all. This is David from the Mr. Black YouTube channel. Hope you all have a good rest of your day, evening, or night. Take care.